All right, today we're going to start our section on graph theory. This is 4.1 in your book, Discrete Mathematics, an open introduction, which you can access through their website. So let's look at the definition of graph, which is very mathy, but we will then sort of unpack it and see what we're actually talking about. When we start looking at sketches of these, representations of these things, they'll be very familiar looking. Okay, so the definition is a graph is an ordered pair, G, of sets, V and E. So there's two sets. One set will be the set of vertices, and one set will be the set of edges. So the vertices tell you how many nodes there are, and the edges tell you which nodes are connected. So every element in E will be labeled as a pair of elements from V, and the endpoints are just telling you, and the labels are just telling you what the endpoints of that edge are. So let's look at an example of this and see that it's not really that big a deal. So let's start with a graph. So here's my graph. It's going to have 4 vertices. So there's my vertex set. And then I'm going to have an edge set. And we're going to label edges this way as just pairs like next to each other. So AB, AC, BD, CD. Okay, and so this is a graph. So here are my vertices. So here's my set V, and here are my edges. These edges are just pairing up endpoints from here to show which ones are connected. So we can draw a representation of this. There's no one correct representation as long as it has 4 vertices and they're connected this way. You have this graph. You have a representation of this graph. The graph itself is really just this data. It's not a physical object at all. Okay, so let's put these down. So maybe we'll just do them in order going around, but it really doesn't matter. So here are my 4 vertices, and then all I need to do now is connect them according to these rules. So the first one is A to B. The next one is A to C, B to D, and C to D. Okay, so here's a representation of that graph. Notice that the edges cross here, but there's no vertex here, so there's not like really an intersection there. So here's one representation. But you didn't have to do this. You could do it other ways, right? So here's another representation. So maybe we want to draw it where those things aren't crossing. So we can go A, B, and then we'll put D down here. So we're sort of untwisting these two edges. And then put C over here. And then go back to our edges. This is telling us how to connect them. We go A to B, A to C, B to D, and C to D. So these are both good representations of this graph. And of course, there are an infinite number of them. Any way you can arrange 4 dots in a plane will give you a representation.